To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello dear grade 7 children. Today we are going to start the 7th lesson of the textbook, that is forms of energy and uses. Now this is not the first time you are going to discuss about energy. Even last year in grade 6 also you have discussed about energy. So what are the topics that we are going to learn under this lesson, children? Let's see. Right. So these are the topics that we are going to learn. Kinetic energy, potential energy, electrical energy, sound energy, light energy, heat energy. One other name given to heat energy is thermal energy, chemical energy. Right? So do you remember in grade 6 that you all have learned the things in the environment can be divided into two things as matter and energy. So matter are the substances with a mass and that occupy space in the environment. What about energy, children? Now energy doesn't have a mass and at the same time energy does not occupy space in the environment. So under this lesson we are going to learn about different types or different forms of energy and their uses. Forms of energy and uses. So we are going to learn what are these different types of energy and how we can use these different types of energy to do our day-to-day activities. So let's get started. Right, children. Now look at these pictures. You all can see. Now here running a vehicle. Right? Lifting a weight. Rotating a fan. Running. What are these things, children? These are known as different types of work. Okay? We do various types of work in our day-to-day life. Now these are some of these examples. Okay? Animals and machines also do work. Now here when you consider a vehicle, it has an engine. It's a type of a machine. Right? And when you consider the fan also, it's a type of a machine. Right? So now here, this human is lifting a weight. Okay? Now this person is running. Okay, children? And at the same time, animals also do work. What are the work done by animals, children? Sometimes they have to catch their prey. So accordingly, they have to run to catch their prey. So some of the animals climb trees. Some other animals like aquatic animals, they have to swim. So those are the different types of work done by the animals. Okay, children? So what are the other examples for different types of work that we do in our day-to-day lives? So from morning to night, you do a lot of work. Some of this work, you need a lot of energy to do this type of work. For example, like lifting a weight and running, you have to have a lot of energy, right, children? So what are the other types of work that you do, children? So you have to write your notes and you have to go to school. You have to wash your clothes. Those are the different other types of work that you do in your day-to-day lives. So let's move to the next. Right. So in addition to those mentioned above, people engage in different types of work in day-to-day life. So previously only 4 examples were given. Okay? So can you give some examples of such work? Now we all can give many examples for different types of work that we do in our day-to-day activities, day-to-day lives. Okay? So we have to do this assignment. Now this assignment, before I explain, you all can do very easily. Okay? Let's see. Give 5 examples for instances of doing work in day-to-day life. Now we already discussed what are the other types of activities or work that we do in our day-to-day lives. So start to write down these, children. Now without my help, you all can do this assignment very easily. Now here we are asked to write only 5 examples, but I am sure you can write many more examples under this assignment. Right. I'll show you some of these examples, children. Number 1. So instead of the examples given before, we have to write some other examples. We can write number 1, carry in a bag. Carry in a bag. Then what can we write? You can write your own examples. I will show you some of these things, right? Writing with a pen. Writing with a pen. What else? We can write opening a door. Opening a door. Right? So sometimes at school you all have to move your desks and chairs. So in that case we can write that as well. Push in a desk. Push in a desk. At the playground you need to throw balls. So in that case we can write that as well. Throw in a ball. Throw in a ball. Right? So these are some of the activities, some of the work done by you all in your day-to-day lives. Okay? So apart from these things, so most of these examples are coming under when you're at school, you do this type of work. Okay? So at home also you do another set of work, right? Sweeping the floor, right? And washing your clothes. Those are the other types of work that done by you all when you are at home. And you can, in this, when you are writing down this list, right? When you are completing this assignment, you can include the other type of activities done by maybe your parents as well, right? So let's consider if your mother cooking food, right? Washing dishes. Those are also coming under different types of work. Okay, children? So when you do this activity, you have to make even though here it says to write 5 examples, you can write more and more examples in order to improve your knowledge. Okay, children? We'll move on to the next. Okay. So it's clear that man as well as animals and machines do a lot of work. So nowadays, in order to make our work easier, most of the time we use different types of machines. Right, children? So for example, in order to wash our clothes, we can use a washing machine. Some of us use washing machines. So in that way, it's very easy to do our work. Okay? But still, the work done is washing clothes. So we can do it manually or using a machine. Okay, so we can use machines also to get our work done. Right, children? So now let us consider what is needed for man as well as other objects to do work. So we discussed that we engage in a lot of activities during our day-to-day lives. We do a lot of work. What do we need to do work, children? Now this activity we are going to do to understand that, okay? So the activity is testing what is needed to do the work, right? So what are the materials? What are the things we need, children? We need a bicycle tube, or we can even use any other stretchable band. Okay, children? We need a bicycle tube. So bicycle tube is a stretchable band, okay? So piece of a bicycle tube. And we need a meter ruler. Let's write a piece of bicycle tube and meter ruler. A piece of bicycle tube and a meter ruler, okay? Right. Let's see. So what is the method? Now look at this child. He is stretching the bicycle tube, okay? So how to do this activity? Now remember, children, this activity is very easy to do. Even at home, you all can do this activity, right? So when you're in the classroom, you can do this activity with your friends. So when you're at home, because you don't have the friends, you can do this activity with your family members, okay? Let's see. Give the strip of rubber tube to each student and tell them to stretch it as much as possible. Very interesting activity, right? Note down the maximum length that each student stretched. Right, so what do we have to do now, children? We have this piece of bicycle tube. We have to give it to each student and we have to ask them to stretch it as much as possible. So you are going to realize a nice thing when you do this activity. There are some children who can stretch it very well. There might be some other children who cannot stretch it that well, right? However, when they stretch, when each student stretch this one using the meter ruler, you need to measure the length, which means now when you consider this child, he is stretching this band this much, you all can see, right? So this length you have to measure using the meter ruler, right children? So I'm going to show you this activity. Now in the lab, I'm going to show you this activity, how to do this. There I'm going to use two types of bands, okay? Let's go to the lab and see this activity now. Right children, you all know that we do a lot of work in our day-to-day life. So what do we need to do this work, children? So by doing this activity, we are going to check what we need to do our work, okay? So what do I have here, children? Look at this. Here I have a meter ruler. And here I have a bicycle tube and here I have a elastic band. So when we consider this bicycle tube, this is a piece of bicycle tube and an elastic band. When we consider these two bands, there's a certain characteristic they have. What is that, children? You all have learned this is called elasticity, right? You all can see we can stretch them. Okay, even this one we can stretch very easily. Okay, so this property is known as elasticity. Right, children? So this activity you all have to do with your classmates. Okay, now here I am going to show you all how to do this activity. First of all, I will take this piece of bicycle tube. Look at the length of this band, children. It is about 14 inches. Right? Now I am going to stretch it a little. So when I stretch it, what is the length? You all can see it is about 16 inches. Right. If I want to stretch it more, what do I have to apply? If I want to stretch it more, I have to apply more energy. Right? It's very difficult to stretch it more and more. Okay, now it's about 18, you all can see, but it's very difficult to stretch it that much. Okay, children, if I take this one, right, you all can see its length is about 8 inches. Right, children? And it's very easy to stretch this band. Look, now I can very easily stretch it up to 12, 15, even 18. Right, children? So when we take different types of bands, this elasticity depends on each material. Okay, so when I consider this one, it's very difficult to stretch, but this one can be stretched very easily. Right, children? So when you do this activity in the classroom, you will realize some children can stretch these type of bicycle tubes more and more. And some children, they cannot stretch it more. What is the reason, children? If someone can stretch this type of bicycle tube more and more, which means those type of people have a lot of energy. It all depends on the amount of energy in your body. Okay, children, if you have more energy, you can stretch this more. If you don't have much energy, you cannot stretch it more. Okay, children? Right, children. So you watched the experiment. I hope it's very clear. There what I did was I used two different types of stretchy bands to do this activity. There when I used that black color band, it was a little difficult to stretch that one. But the elastic band was very easy to stretch. Okay, children? Right. So when you do this activity, you have to make a table like this. So at school or at home, you can do this activity. So you have to write the names of the students or your family members, and then you have to write the maximum length stretched here. Right, children? So you can put numbers and write the names or the family members. Let's say if your mother, father, likewise also you can write. Okay, and maximum length stretched in centimeters you can write here. There you are going to realize that different children can stretch this band in different levels, different lengths. Okay, children, and you are going to realize the stronger people can stretch it very easily, more and more. Okay, children, which means like the children or the family members who applied more energy. If they have more energy, they can stretch it more. Right, children? And another thing, let's say that if you do it activity at one time, let's say you are going to do the same activity another time as well. Let's say when you are very tired, if you are trying to do this activity, you will realize even before you stretch it very well, when you are very tired, you cannot stretch it that well. Okay, so we are going to discuss the reasons later, right? So you have to write the names and the maximum length stretched. So what is the conclusion? So after doing this activity, we can write as the conclusion, different children can stretch it at different lengths. The one who applies more pressure or more energy can stretch it more. Okay, the stronger ones can stretch it more. We'll write the conclusion. Different children, or we can simply write stretch the band at different lengths. Different lengths. Children who apply more energy can stretch the band more. Right, children? Children stretch the band at different lengths. Children who apply more energy can stretch the band more. So after doing this activity, now we know that you need more energy to apply this band very well, right? Now when you consider this activity, children, what is this stretching the band? Stretching the band is a type of work. So earlier we learned different examples, many examples for different types of work that you do in your day-to-day lives. They are opening a door, writing with a pen, carrying a bag. They were included under different types of work, right? The same way, stretching this band is also a type of work, right? So now you know that you can stretch this band more and more, which means very well if you apply more energy, right? Which means the ones with more energy can stretch it more. So we can come to a conclusion that energy is needed to do work, right? So to understand this better, we are going to do a similar activity next, right? So for now, children who apply more energy can stretch the band more, right? So now we are going to do another activity similar to this one to understand this better. We'll move on to the next, right? So this is the second activity, the same topic, testing what is needed to do the work. Even earlier activity we did to test the same, okay? So materials needed. We need a thread, about 1 meter long. And we need a laboratory stand and a small stone. We'll write a thread, a laboratory stand, and a small stone. Right? A thread, a laboratory stand and a small stone. So how to do the activity? Let's see. Here. You have to hang the stone on the laboratory stand using the thread. Okay? We'll label this. This is the thread. This is the stone. So the laboratory stand is not given in the picture, but that's where you are going to hang this on. Thread, stone. Right? So how to do the activity? Tie one end of the thread to the piece of stone like this. Tie the other end of the thread on the stand. Right? Give the hanging stone a push. So after hanging this one, the stone should be still. Right? So without moving, it should be still. Then what you have to do, give the hanging stone a push. Right? You have to push it a little bit and you have to observe what happens. So you will realize the stone will move to either side. That is what given in these dotted lines. Right? So the stone is going to move to this side, comes back to the same place, then again to this side, again comes back to the same place. So like that, like a pendulum, it's going to move to either side. Right? Observe the motion of the stone for a long period of time. It depends, children. So when you push the stone, if you pushed it only a little, it's going to move on to either side, and within a short period of time, you are going to observe that this will stop. But if you push it more, then what will happen? It will move to either side for a longer period of time and it will take more time to stop it. Okay? Now we are going to do this activity in the lab. Right, children? Now we are going to observe the motion or the movement of this weight that is tied with a thread. Look at this one, children. This is a weight that is tied with this thread. Okay, therefore we can move it here and there. So when you do this activity at home, you all can do this activity by tying a stone with a thread. Okay, so at the moment this is not moving, right? I am going to give a little push. You can see it is moving to either side. You all can see it is moving. Look carefully what happens to the movement of this weight. Right. If you observe carefully, you will see that the distance it moves to either side little by little reduces. Okay. So earlier it started with more distance. Now little by little the distance is reducing, children. Right. Right. You all can see now it moves very slowly to either side. Okay? Right. So why does this happen, children? So when I move this one, it gets a certain energy. Because of the energy it has, it can move to either side. But as it moves little by little, it reduces its energy, and that is why the distance it moves reduces little by little. Right. Now you all can see it is not moving to either side anymore. Very slowly it's moving. That is because now it doesn't have enough energy to move to either side. Okay, children. So for this movement, it needs a certain amount of energy. According to the little push I gave, it gained that energy, and according to the energy it had, it moved to either side. So if I want to move this weight for a longer period of time, what do I have to do, children? I have to push it more. So when I push it more, you all can see this time the distance it moves is much higher than that of the previous time. Okay, children, so if you carefully observe this type of movement, you will see that this motion remains for a longer period of time than before. Right, children. So you watch the experiment. I hope it's very clear now. Even this activity you all can do at home very easily. You don't have to wait for the teacher to do this activity, children. You all can try this activity at home very, very easily. Okay. So what is the observation? What did we do again? This hanging stone, when it was still, we pushed it. We gave a push, then it started to move to either side. Right, children? So then what happens? With time, what happened, children? Earlier it started to move to either side, but with time, we observed it for some time. Then what happens? The speed of motion. It reduces with time. And finally, what happens, children? The stone stops. But what happens if we push it more? If we apply more energy to push it, it can move for a longer time. Which means when we push it in the first instance, it gains some energy because of the energy we apply, right? To push this one, we apply our energy. So the stone gets that energy. Because of the energy it has, it starts moving. So gradually, this energy decreases, and finally, when there's no energy at all, it stops. Right, children? We'll write this one. Observation. Due to pushing, the stone moves to either side. The speed of motion decreases. With time. And the stone stops moving finally. Right, and finally. And finally, the stone stops moving. When more energy is applied to push, the stone moves for a longer time. Okay, children? Due to pushing, the stone moves to either side. The speed of motion decreases with time, and finally, the stone stops moving. Right? When more energy is applied to push, the stone moves for a longer time. More energy is applied, the stone moves for a longer time. Right, children? So what is the conclusion then? So what you have to understand is moving this stone is a type of work, right? So to do this work, what is needed? Energy is needed, children. Right, children? So when the stone is not moving, we need to apply energy to move the stone. So when we apply more energy, more work can be done. What is meant by more work? Moving it for a longer time. Moving the stone is a type of work. How does it get energy? How does it move? With the energy given by us. If we give more energy, it moves for a longer time, which means with more energy, we can do any work further or for a longer period of time, which means more work can be done with more energy. That is the conclusion. Right? Let's write. Moving the stone is a type of work. Therefore, when more energy is applied, more work can be done. Finally, what is the conclusion? Energy is needed to do work. Therefore, energy is needed to do work. Right, children? Moving the stone is a type of work. Right? Therefore, when more energy is applied, more work can be done. Here, when more energy is applied to push, the stone moves for a longer time, which means more work is done. If moving the stone is a type of work, here more work is done. Right? Therefore, when more energy is applied, more work can be done. Therefore, energy is needed to do work. This is the conclusion of the experiment. Right? Energy is needed to do work. Without energy, we can't do work. Right? We'll move on to the next. Right. Work can be simply explained as a push or a pull. What is the meaning of this one, children? A push or a pull. Resulting in a movement of an object. To do any work, we need to push or a pull. So for an example, we can take lifting a bag. Let's say that when the bag is on the ground, we have to lift it up. When we lift it up, you all can see it shows us pulling. Right, children? When we keep it on the ground again, it's like pushing. Pulling and pushing. Right? When we open a door, let's say that we have to open a door to this side, which is pushing. When we have to close the same door, you have to pull it to the other side. Right, children? So when we ride a bicycle, let's say that we'll take this as an example. If this is the bicycle wheel, right? So riding the bicycle, let's say that this is the pedal, this is the leg. So with your foot, you have to pedal the bicycle. There what happens? When you have to rotate it to this side, with your foot, you have to push it back. Right? When you push it back, it goes to this side. Again, you have to rotate it as a circle. When it is this side, what happens? You have to pull it to front side. Like this. Right, children? Pushing and pulling. Right, children? So if you think about, now when you consider opening a tap, from one side you have to push, from the other side you have to pull. Right? When you open the tap, from one side you have to push, the other side you have to pull. So pushing and pulling. So doing a work can be simply explained as a push or a pull, resulting in a movement of an object. Right? In order to move an object, we have to either push or a pull. Right? So it's clear that work is done when stretching the strip of the rubber tube and moving the stone in the above activity. So we did two activities to understand this, right? That stretchy band activity and moving stone activity. So both the instances we consider stretching the rubber strip and also moving the stone. They both are different types of work. Right, children? So when you stretch the rubber band, what happens when you stretch the stretchy band? It is pulling, right? When you move the stone, you have to give a little push, that is pushing, right? So in order to move the object, you have to either push or a pull, right? So work is done, okay? So look at this one. The ability to do work is known as energy. So in the previous activity, we discussed that when more energy is applied, more work can be done, which means energy is needed to do work. Okay, children, so what is energy? So we can define energy in another way. The ability to do work is known as energy, because to do any work, we need energy. Without energy, we cannot do any work. Right, children? Therefore, the ability to do work is known as energy. Right? The Standard International Unit or SI unit of measuring energy this is known as joule. The symbol is capital J. Symbol is given within brackets. Right? The SI unit or Standard International Unit of measuring energy is joule. Right, children? So at the end of these two practicals, experiments, now we know that the ability to do work is known as energy, and the SI unit of measuring energy is joule. Right? So what is work again? Work means a push or a pull. Okay, children? We'll move on to the next. Right. So here, energy is necessary to perform work. We can't do any work without energy. Okay? To increase the amount of work done, the amount of energy applied should be increased. So do you remember in the second activity we did, when we apply more energy, when we push it harder, it can move for a longer period of time. Right, children? So for example, you should supply more energy to move the stone further in the above activity. Right? So energy exists in different forms. Now what is energy again? Last year we learned energy is also a part of the environment, right? It's a certain type of thing around us, right? There are different forms of energy, right? So energy exists in different forms. Now in the next activity, we are going to consider what are these different types of forms and what happens when we use different types of energy, okay? Now let us consider the different forms that energy or the ability to do work can exist. Let us pay attention to some different types of work done and different forms of energy used. So for this one, we are going to do a very interesting activity, right? Okay, so the activity is identifying various forms of energy. So in this lesson, we are going to learn different forms of energy and how can we use different types of energy to do work, okay? Right. So what are the materials we need? We need a lot of materials to do this activity. But it's a very easy activity, children. Even this activity, you all can very easily do at home, okay? So we need a torch bulb, dry cells, piece of wire, and we need a battery-powered wall clock. And here we need a musical greeting card. You all know that some birthday cards are there. As you open it, it plays music, right? You need that type of birthday card. And you need a dynamo, bicycle dynamo. And you need a small radio. And you need some small toys. You must have seen some toys. Now here, even in this small toy car, you can see there's a key. There are some winding toys, right? There's a small key to wind it up. So after winding, when you release the toy, for example, if it's a car, it starts moving. Without winding, you can't move it. Right, children? And you need these type of some winding toys and battery powered toys as well. Right? And we need a small motor and a small table clock. Right? Here you can use a winding, if you can find a winding clock, that's better. Or you can even use a small clock that is a battery powered one. Okay? So instead of this one, we can use a stop clock as well. So in the lab, I'm going to show you all a stop clock here. Right, children? We'll write. Torch bulb. Dry cells. Pieces of wire. Battery powered wall clock. Musical greeting card. Bicycle dynamo. Radio set. Winding and battery powered toys. Small motor. And here winding table clock or a stop clock. Right, children? Torch bulb, dry cells, pieces of wire, battery powered wall clock, musical greeting card, bicycle dynamo, radio set, winding and battery powered toys, small motor, winding table clock or stop clock. So apart from these things, if you are doing this activity at home, you can find other small instruments as well. Different types of appliances you can use, and we are going to check how they work, what are the different types of energy produced when we use those different types of equipment. Okay, so how to do the activity? The method. Study as groups how the given equipment works, right? So at school, when you do this activity, you can take these different equipment given to different groups, and you can check how they work with different types of energy. You will realize that each equipment, these instruments work with different types of energy, right? So identify the main forms of energy that made each piece of equipment work, right? And identify other forms of energy created when functioning the equipment, right? So when you consider these different types of equipment we are going to use, you will realize they will work by using different type of energy, one form of energy, and while working, they will produce another form of energy. Right, children? We will do this activity now in the lab. Right, children. Now we are going to identify different forms of energy that we use in our day-to-day lives. Okay? Right. Look what we have here, children. Here we have 2 dry cells and 2 wires, and we have a small bulb, and here we have a small motor with a small fan. We have a toy car. Here we have a laboratory dynamo model, and here we have the stop clock and a wall clock, and here I have a musical birthday card. Okay, right. First of all, I am going to connect these wires to the dry cells. Right. And then I am going to connect the other ends of these wires to the bulb. Right. What happens, children? The bulb lights up. How did the bulb light up? Because electric current passes through this setup. Right? When an electric current passes through the bulb lights up. Right. So to make this work, so lighting a bulb is a type of work. How did we do this work, children? Using electric current. So what happens? Electric current, when it passes through the bulb, this electric current converts to light energy. Using the electric current, light energy is produced. Not only light energy, children. Now when I touch the bulb, I can feel it's warmed up. Right? So I can feel the warmth of the bulb, which means using electrical energy, light energy and heat energy both produced. Okay, children? Right. Now I'm going to connect this small motor to the 2 dry cells. Okay? Observe what happens. What happens, children? The small fan that is connected to this motor rotates. Right, children? So rotating the fan is also a type of work. How did we do this work? Again, we did this work using electrical energy. Okay? So here using electrical energy, this fan moves. Now, what is the type of energy contained in the moving fan, children? Remember, children, any kind of moving object contains an energy called kinetic energy. Okay, so here what happens? Using electrical energy, kinetic energy is produced. Okay, so when we use this small motor with fan, what happens? The fan rotates. Therefore, using electrical energy, kinetic energy or the energy contained in moving objects is produced here. Now, what else you can observe, children? So when the fan rotates, you can hear the sound. So not only kinetic energy, when this fan rotates, sound energy is also produced. So how did we produce this kinetic energy and sound energy, children? Using electrical energy. Right. Now I'm going to take this musical birthday card. Now when I open this card, see what happens. You all can hear that music is playing when I open the card. So how does this card work, children? Observe carefully. There's a small battery inside. Okay? Right. Look at this. These are small batteries. So because of the batteries, you all know that batteries and cells, they generate electricity. So using the electricity given by these small cells, so batteries, what happens? Sound energy is produced. Okay? So here in this card, this type of battery is present. Okay? This is a small battery. Right. So here what happens? Using electrical energy, sound energy is produced. Right, children? Here I have a small toy car. You all must have played with these type of toy cars. So this is, you all are familiar with these type of toys. Here there's a small switch. I'm going to switch it on. Right. So you can see the car moves. So how did this car move, children? Look. So there's a place to insert small batteries. You all can see small batteries are there. right? So these are actually known as dry cells. So dry cells generate electricity. Using the dry cells, electricity is generated, and using this electrical energy, this car can move. Now, do you remember I already told you all earlier what is the type of energy contained in the moving objects, children? That is known as kinetic energy. So when this car moves, what happens? Electrical energy is converted to kinetic energy. Not only that, when we switch this on, you all can hear the sound of the car as well. So using electrical energy, kinetic energy and sound energy is produced. Right, children? Look at this one. Here we have the laboratory dynamo model. Right? So in the electricity lesson, we all learn about this type of dynamos. Okay? Right. Look, how can I make this dynamo work? You all can see this is the small dynamo and there's a small wheel like this. So there's a small part that I can use to rotate this dynamo. Okay? And here there's a bulb. Now at the moment the bulb does not light up. So for the bulb to light up, an electric current should pass through this bulb. What happens when I rotate this small wheel? Observe what happens. You all can see the bulb lights up. Okay? You all can see the bulb lights up when I rotate this wheel. So what happens, children? When I rotate this wheel, what happens? The dynamo can generate electricity. You all can see this cap-like part of the dynamo is connected with this. It touches this wheel. Okay, therefore, when I rotate this wheel, what happens? The cap-like part also rotates and thereby electricity is generated. So because of the electric current generated, that electric current passes through the bulb and that's why we can light the bulb up. Okay. So here what happens? We produced electrical energy. Right? How did we produce electrical energy? Using kinetic energy, because we had to rotate or we had to move this wheel in order to generate electricity. Only when we rotate this dynamo setup, we can generate electricity and light the bulb. Right, children? So how did we generate electricity? By rotating. Right? By rotating this wheel, we can generate electricity. So when we rotate something which is moving, what type of energy is used there? Kinetic energy. So using kinetic energy, we can generate electrical energy here. Okay? Look at this one. This is a wall clock. You all can see very clearly the arms are also moving. Right? So how do these arms move, children? You all can see there's a dry cell over here. Right? So dry cell generates electricity. Using the dry cells, these arms can move. So therefore, using electrical energy, kinetic energy is produced. Okay, so kinetic energy is the energy contained in these moving arms. Understand, children? And you can hear a small sound as well. So therefore, using electrical energy, kinetic energy and sound energy is also produced, right? Now look at this one. This is the stop clock. Now when I put this lever-like part down, it starts to work. Right, children? Okay. How can we make this work, children? I will show you inside of this stop clock. Observe carefully. You all can see certain machine-like parts present here. Right, children? You all can see there's a key. So even though you can't see, a spiral spring is present here, children. What is a spiral spring? So some of these type of equipment use spiral springs. So here this is the key. When we rotate this key, we can wind the spiral spring up. So here we can't see the spiral spring because it is covered with the other setup. Right? Observe this one. Check whether you can understand this. Now, this is a part of a toy. If you observe carefully, you can see a spiral spring here. Right, children? Observe, this is the spiral spring. So there's a small key here. Look what happens when I rotate this one. You all can see some parts of the spring outside. So look at this spiral spring, children. Can you all see this silver color parts with turns? Right? So look what happens. I am going to rotate this key. Okay? Right. What happens, children, when I rotate this one? You all can see that spiral spring becomes smaller. It winds up inside this setup. Right? I am going to release this key. Now what happens? You all observe that it came out again. Right? So you all can see when I wind this up, what happens, children? You can't see it anymore. That is because it becomes smaller. It goes and compact inside the setup. I am going to release this key now. What did you observe, children? You could see that that spring comes out again, which means it becomes bigger like before. Now again, when I wind it up, check what happens. Right. Again, it becomes smaller. It winds up very well. Right? When I release it, it comes out again. So this type of spiral spring is present inside this stop clock. Right? Some of the table clocks also contain these type of spiral springs. These are known as winding clocks. Okay, and sometimes certain toys also, winding toys also contain these type of winding spring or spiral spring. Okay, children? So what happens, children? When we use this type of spiral springs, when we wind it up, what happens, children? It stores a certain amount of energy, a certain type of energy. This energy is known as potential energy. Okay, children? So when we wind it up, it stores a certain type of energy which is known as potential energy. Right? So when we release the key, what happens? This potential energy is released, and now let's consider that if this contained in a toy car or another toy, another winding toy. So we can move the toy after winding it up. When we release the key, the toy car or the other winding toy moves because of the releasing of this potential energy. Right? So here what happens, the potential energy stored inside the spiral spring is converted to kinetic energy. That is why that toy can move when we release the key. Right, children? So after doing this activity, I hope you understand that there are different forms of energy that we use in our day-to-day lives. Right, children? So the activity was very clear, I think. So as I told you all, try to do this activity even at home. I'm sure you will understand it better, okay? So here, observation, what do we have to write? The name of the equipment, main form of energy that made the equipment work, and other forms of energy created, okay? So the first example is given, electric bulb. So when you light a bulb, what happens? What is the main form of energy that made the equipment work? The small torch bulb works because of the electricity supplied by the dry cell. Right? The dry cell provides electricity. Because of the electrical supply, the electric bulb works. So while working, the other forms of energy created. What is the main form of energy created when we light a bulb? Light energy. Right? So after a little while, if we touch the bulb, you will realize that the bulb is heated up. Therefore, other than light energy, it produces heat energy as well. Right, children? We will write the other examples as well. So what are the other things we used? Here we can next write this one, battery powered wall clock. Right? Wall clock. Wall clock. First we will write these, no? And then we can write a greeting card, dynamo. We will write greeting card. Greeting card. dynamo, radio, then what else? We can write winding car, battery powered toy, both. Small motor, and during the experiment we used a stop clock, right? We can write winding car, winding toy, winding toy, stop clock, and the small motor. Right. Here we will write small motor, and we will write finally dry cell as well, because to make most of these equipment work we have to use the dry cell. How does the dry cell work? We are going to discuss. Therefore, finally I am going to write the dry cell as well. Okay. So when we consider the wall clock, the battery powered wall clock, so they use with dry cells. So what is the main form of energy that made the equipment work? Because dry cells supply electricity with electricity, electrical energy. Electrical energy. So what is the other forms of energy? Are there any other forms of energy created here? Now you all know that because of the electrical energy supplied by the dry cells, this wall clock start to work, which means the arms move, right? Do you know that all the moving objects contain a certain type of energy? Now, under this lesson, we are going to learn, okay? So, the type of energy contained in the moving objects is known as kinetic energy. Right, children? So, here, other forms of energy created, kinetic energy. So when these arms move, sometimes we can hear the ticking sound as well. Therefore, sound energy is also created. Kinetic energy, sound energy. Okay, children? Greeting card. There I showed you all greeting card also has a small battery. Now battery, in the electricity lesson we learned that all the batteries, dry cells, they contain chemical substances. Okay, now because the greeting card had a battery or small battery, there it generates electricity. Therefore, because of the electricity generated by the small battery, the greeting card works. It produces music. Okay, so we will write again electrical energy. Right? So as you open these type of cards, it plays a music, which means sound energy. And some of these cards have a small LED bulb. In that case, light energy is also created, produced. Okay? We will write sound energy, light energy. Right, children? Dynamo. What about the dynamo? I showed you all how to make the dynamo work. Right? There was a bulb fixed to that dynamo. When we rotate the wheel, what happens, children? The small bulb lights up. Which means because of the rotation of the dynamo, electricity is generated. Because in order to light the bulb, what happens, children? Electricity should be there. Right, children? Therefore, when we rotate the dynamo only, electricity is generated. So, if we rotate it, what type of energies should be given here, children? Kinetic energy. I told you all, any type of moving object contains a type of energy called kinetic energy. Therefore, using kinetic energy, dynamo can generate electricity. Right? So let's write kinetic energy here. Using the kinetic energy, the dynamo can generate electrical energy. Right, children? Radio. So the battery powered radio, it works because of the electrical energy. Right? Even if you have to plug it in, it's still electricity. Because of the electricity, radio works. What are the other forms of energy created? Sound energy, and radios have small bulbs. Therefore, light energy is also created. Right? Let's write electrical energy, sound energy, light energy. Okay, children? The next one, winding toy. Now, what do you think that happens in a winding toy, children? In a winding toy, there's a key to wind it up. There, what happens is, inside these type of winding toys, children, there's a spring. Okay, there's a small spring. So, the spring present like this. Right? So, when you wind it up, now we can't see this spring from outside, but this spring is connected with the key. So, using this key, you are going to wind up this spring, right? So, when you wind it up, these small rounds get closer to each other, right? Like this, they get closer to each other. Right, children? So, when they get closer to each other, a certain type of energy is stored inside this spring. That energy is known as potential energy. Potential energy. Right? So, due to winding, you all can see the shape of the spring is going to change. Because of the change of this shape, it stores a certain type of energy which is known as potential energy. Right? So, when you release the key, what happens? This spring again goes back to its normal position. Right? While it's going back to its normal position, it makes the small toy moves. Right, children? Therefore, potential energy, when it goes back to the normal position, the small toy car moves, or the small toy, the winding toy moves, which means it moves means then it contains kinetic energy. Because of the potential energy, kinetic energy is created. Right, children? So, winding toy, potential energy. When you wind it up, we store potential energy. And when we release the key, it will become kinetic energy, right? Kinetic energy. Right. The next one, stop clock. Remember, stop clock also has the same method. There's a small spring inside. When we wind it up, what happens, children? Its shape changes. Right? The spring is something like this. When you wind it up, these turns get closer to each other. Because of change in this shape, it stores a certain type of energy called potential energy. When we release the key, what happens? Because of the potential energy stored in the spring, it slowly start to go back to its original position. While it's going back to its original position, as it is connected with the other parts of the stop clock arm starts to move. Okay? So, we will write here also potential energy. Converts to kinetic energy. And the sound is also created, right? Now, even both the instances, even the winding toy, when it works, sound is also created, right? So, both the instances, sound energy is also there. Sound energy. Here also sound energy. Right? Small motor. Small motor rotates when you connect it to a small circuit, right? Even during the electricity lesson, we learn about these type of motors, right? It rotates. Its axis starts to rotate when we supply electricity, right, children? Therefore, when you connect it to a electrical circuit, electricity is supplied to the small motor. When electricity is supplied, it starts rotating. Its axis starts rotating, which means if it's rotating means a kind of movement, therefore kinetic energy, right? Electrical energy. Electrical energy. Kinetic energy. And also sound energy. When the motor rotates, sound is also produced, right? Sound energy. Right, children? So finally, even though not a main equipment, I included the dry cell also in the list. Right? So you all know now here in the small motor, right? In the greeting cards, in the wall clock, all these, these equipment were powered by these batteries or dry cells, right? So in this case, we have to write the dry cell as well. So where did the dry cell get the energy to generate electricity? Now you all know that in the electricity lesson, we learned that there are different methods of generating electricity. One method is using electrical cells. So these type of dry cells contain chemical substances, therefore they are known as chemical cells as well. Because of the chemical reactions, electricity is generated. Right, children? So in the dry cell, because chemical substances are stored inside, what is there? Chemical energy is present. Their chemical energy is converted to electrical energy. Because of the chemical energy, when we use the dry cell, electrical energy is produced, okay? We will write chemical energy. Chemical energy. And the other forms of energy created, electrical energy. Right, children? So you can use different types of other instruments that you can find at home and you can do the same activity, right? So when you use more and more other equipment, you will understand this one better. So you are going to realize that using one type of energy, these type of equipment going to work, and when they start to work, they produce different other types of energy. Okay, children? So this is how we do the activity. So after doing the activity, I hope it's very clear that there are different forms of energies used to make a certain equipment work. While making them work, what happens? Other types of energy, other forms of energy is also produced. Okay? We'll move on to the next. Right. So different forms of energy. Now we can write the list of the energy that we discussed in the previous activity. We will write them. Number 1, we discussed about electrical energy. Electrical energy or electricity. Sound energy. Then we discussed about light energy. What is the energy contained in the moving objects, children? Kinetic energy. And what type of energy is contained in winding springs, children? potential energy. Potential energy. And then we discussed about heat energy. Now heat energy is known as thermal energy as well, right? Heat energy or thermal energy. And finally we discussed about chemical energy. Right, children? So different forms of energy: electrical energy, sound energy, light energy, kinetic energy, potential energy, heat or thermal energy, and chemical energy. Right? So under these topics we are going to further discuss in this lesson. Right? So we have completed the first chapter of this lesson. Do you remember what we learned in this chapter, children? Now we learned that we do different work in our day-to-day lives. So after doing 2 activities, now we know that what is needed to do work, children. We need energy to do work, right? And further we learn that there are different forms of energy. There are 7 different types of energy we discussed in the last activity. Right, children? So we are going to discuss about each type of these energies in the next chapters.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.